Section 7.1, Ratios and Proportions. A ratio is a comparison of two quantities. Here my two quantities are x and y, and my ratio can be written several different ways. First, x to y. Second, I can have a colon in place of the 2, but still is read x to y. And finally, I can have a fraction, and that's also read as x to y. And remember that in a fraction, your denominator cannot be 0. Here I can replace those variables with numbers, 3 to 4, 3 to 4, or with a fraction 3 to 4. Also, when representing ratios, I always want to write them in simplest form. Here, a teacher increased his 4-inch wide by 7-inch high cylinder picture to a 3-foot wide by 4-foot high poster for his class to see. What is the ratio of the width of the poster to the width of the picture? Here, when I write my ratio, it has to be in the order that they're requesting. Here they want the poster compared to the picture. So when I write my ratio, and it can be written any 3 ways as shown on the slide prior to this, but when I write that ratio, the poster part must come ahead of the picture part. Also, when I take a look at my picture, it's done in inches. My poster is done in feet. So I need to convert my feet to inches when I write my ratio. Here my poster must be first. I'm doing the width, so I have 3 feet. When I convert that, I know 3 feet is 36 inches. And when I write my ratio, it can be a 36-inch width for my poster compared to 4 inches for my picture. Or I can write that as a fraction. And I also could write this just as 36 inches to 4 inches. And that's how they're all read. Then I want to simplify that ratio. And when I simplify it, it will be 9 inches compared to 1 inch. So my ratio for the width of the poster to the picture is 9 to 1. I could do that also with the height of these cylinders, compared the poster to the picture. And if I did in that order, poster to picture, I would have, again, my poster, which is going to be 5 foot. When I convert that to inches, I'm going to have inches being 60 inches. Then I put that into a ratio, 60 inches compared to 6 2/3 inches. When I put that into an improper fraction, that's going to give me 20 thirds inches. Or I also can write that as a fraction, which would be 60 over 20 thirds. Now I can simplify that. 60 divided by 20 thirds. 60 times reciprocal, 3/20. Then I just simplify that, and I will get 9. Therefore, this ratio is 9 to 1. And that should be exactly what I have on my first ratio, 9 to 1. A proportion is a statement that two ratios are equal. Here I have A to B equals C to D. And that also can be written as the colon form, A to B equals C to D. Here I have substituted in for those variables, and I have 12 to 14 equals 18 to 21. And similarly, I have 12 to 14 equals 18 over 21. Again, I can simplify these to make sure they're equal. Here, I would divide by 2, and I would get 6/7 equals. And when I divide by 3, I get 6/7. Therefore, you can see this proportion has a statement that two ratios are equal. An extended proportion is when 3 or more ratios are equal. Here I have 9 to 15, 6 to 10, and 3 to 5. And I can prove that they're equal just by simplifying. Divide by 3 on the top and bottom. I get 3/5. Divide by 2, top and bottom, I get 3/5. And my last ratio is 3/5. So here I have 3 ratios that are equal. This is an extended proportion. Here I have properties of proportions. And if I have a proportion such that A to B equals C to D, then that proportion is equivalent to the following 4 properties. The way that I like to explain this is we take a look at the beginning of each of these properties, and then we follow the pattern to replicate what that first section had. For example, here I have A times D. If I go back to the original proportion, A times D. So I took the numerator and multiplied times the opposite denominator. In similar fashion, I'll take C times B, and that's exactly the solution. On number 2, I have from the problem B over 8, and when I go back to the original proportion, I have B on the bottom and A on top. All they did is find that reciprocal. Therefore, the reciprocal here would be D over C. Therefore, B over A equals D over C. Number 3, I have A over C. Back to my original proportion, I took the 2 numerators and put them over top of each other. A over C. Therefore, I'll follow the same pattern and put B over D, and that is my solution. On number 4, A plus B over B. Therefore, I must take the numerator plus the denominator over the denominator, which is C plus D over D. Therefore, for property of proportions, look at the beginning set of information and follow the pattern from my original proportion. Here, if I'm given x to y equals 3 to 7, I want to complete each statement. Here I want to use the property of proportions. In other words, follow the pattern. Here I have 7 times x. 7 times x. Therefore, I need to follow the pattern and take y times 3, but I can write that as 3y. Number 3, 7 over y. 7 over y means the denominators will be put into a ratio, 7 over y. Therefore, I'll use the numerators, 3 over x. Just follow the pattern. Next, I have x plus 3 over 3. So, x plus 3 over 3, I'm going to follow the same pattern. Y plus 7 over 7. Next, I have y over x. Here's x over y. Take the reciprocal, I get y over x. Take the reciprocal, I get 7 over 3. Next, I have x over x plus y. Therefore, I'll have 3 over 3 plus 7, but that also can be written as 3 over 10. And the last, 7 over 3, would be y over x. Therefore, property of proportions is just looking at our initial state and replicating that same procedure from our original proportion. To solve a proportion, we must have a procedure. Here, I have a proportion represented by A to B equals C to D. To solve this, I'd use the properties of equality and multiply both sides by BD. And when I simplify that, I would end up with AD equals BC. In other words, the B's would cancel. I'd get A times D. And here, the D's would cancel. I'd get C times B. But there's got to be an easier method. To do that, that method is called cross product. In other words, I just simply multiply A times D and C times B. And that gives me my equation that I can solve. That's what I have written here. This is the same as multiplying both sides by BD, or in other words, the common denominator of each of my proportions. Another way of stating that is called the product of extremes and is equal to the product of the means. In other words, means extremes. In our ratio, what we have is written A to B equals C to D. The extremes is the extreme values of our ratios. In other words, here it would be our A and D, and they would multiply our mean values of our ratio, B and C. Therefore, I get the means and the extremes multiplied together. The extremes gives me A to D, and the means would give me C to B, which again is just our cross product. Here we want to solve proportions. Number one, I'm given x to 4 equals 5 to 2. By a cross product, I'm going to get 2x equals 4 times 5, which is 20. Here's our equation. Solve for our variable. Divide by 2. I get x equal to 10. Number 2, 7 to 3 equals 8 to y. By cross product, I'm going to get 7y equals 24. Y equals 24/7. And that is simplified. Next, I'm going to get 5 times x plus 2. Here I'm going to write this to make sure that we do this the right way. That is 5 times the quantity of x plus 2 equals 6. In other words, I just don't take 5 times x, I must distribute that quantity. Therefore, that's 5x plus 10 equals 6. Simplifying, I get 5x equals a negative 4, x equals a negative 4/5. In each case, these were solved by cross product, or also by the means extremes method, multiplying our extremes, set them equal to our means. Our next example, I have 5 is to 2x plus 6, 3 is to 2x. Let's use our cross product or means extremes. I'm going to get 10x equal to 3 times 2x plus 6. Bring down our 10x. That gives me, when I distribute, 6x plus 18. Subtract 6x, I get 4x equal to 18, or x equals 18/4, but I need to simplify. And when I divide by 2, that's going to give me 9/2. I can leave that as an improper fraction, but it still needs to be simplified. Next, I'm going to use my cross product rule. A negative 3 times 2x plus 1 equals 5 times 4x minus 2. Distribute, I'm going to get a negative 6x minus 3 equals 20x minus 10. I'm going to add 6x to both sides. I'm going to get 26x. Add 10x. I'll get 7. Divide by 26. I get x equal to 7 over 26. On my last problem, I'm going to use the cross product rule again. Here, when I do, I'm going to get 2x minus 3 times x plus 5, and that will equal a negative 11. To simplify on the left, I need to FOIL. In other words, take each term in the first quantity and distribute through the second quantity. When I do, that gives me a 2x squared plus 10x minus 3x minus 15. And that equals a negative 11. Let's simplify the left side. That gives me 2x squared plus 7x minus 15 equals a negative 11. This is a quadratic, therefore I need to set this to 0. To do that, I'm going to add 11 to both sides. That gives me 2x squared plus 7x. Add 11 to both sides. I get a negative 4. I still have a quadratic, and to solve that, I'm going to factor that expression. Therefore, 2x times x will give me 2x squared. And I need to break up my 4, and I'll break that into 1 and 4. 4 times 2 is 8. 8 minus 1 will give me 7. This will be negative. That will be positive. And that still gives me my negative 4. Therefore, I'm going to solve each. 2x minus 1 equals 0. Therefore, x, add 1 to both sides, divide by 2, I get 1/2. And here, x equals a negative 4. Therefore, our solution is x equals 1/2 and x equals a negative 4.